Sample size. In estimating, the sample size needs to be considered in order to make it more valid and reliable, especially on research. The number of respondents must be considered. The number of members or element of a population must be taken into consideration aside from being manageable. So this is our formula in finding the sample size. Our n is our sample size. Then we have the z-score, z sub alpha over 2, times the population standard deviation divided by the margin of error. And then all of this will be raised to 2. And then of course, our final answer should always be rounded up. Okay, so round up to the next integer. Say for example, if we have 58.1, this should be rounded up to 59. If it's, say for example, 50.9, so this should be 51. Always round up to the next integer. Okay, let's go directly to our examples. A college dean wishes to estimate the average number of hours students spend during doing homework per week. The standard deviation from a previous study is 4.5 hours. How large must his sample size be if he wants 95% confident in finding whether the true mean differs from the sample mean by 2.5 hours? So first, let's have the given. So of course, our n is not given. So what is this 4.5? This 4.5 is the population standard deviation. So this is 4.5. Next, okay, 95%, whether the true mean differs, take note of this word, differs from the sample mean by, so meaning it is the maximum allowable difference from the true mean. So meaning this 2.1 here is our margin of error, 2.1 hours. Okay, so the missing here is just the z sub alpha over 2. Okay, so since this is 95% confident, so we have this table below, so 95%, so 1.96. Okay, so we will now substitute these values to our formulas. So z sub alpha over 2 is 1.96 times the sigma is 4.5 over the error 2.1, then squared. So again, n is equal to the z alpha over 2 times the population standard deviation divided by the margin of error, and then you square that one. Okay, then you use your calculator. So you may copy this on your calculator. 1.96 times 0.45 divided by 4.5 divided by 2.1, and then you square. So the answer is 17.64. And then we always round up to the next integer. So we have 18. Therefore, to be 95% confident that the estimate is within 2.1 hours of the true mean, the college dean needs sample size of at least 18 students. Okay, so 18 students. Next, a department store is interested in the charges made by credit card customers. The GM or general manager of the department store would like an estimate of the mean purchase amount for its credit card customers that is within 500 of the actual population mean. So for 99% confidence level, how large a sample is necessary if the population standard deviation is estimated at 3,800? So we're given with the population standard deviation of 3,800. And then take note of this, that is within the 500 of the actual population mean. So that is our maximum allowable error. So that is of course our margin of error. So that is our 500. And then next, so our z alpha over 2 is here. So 99%. So 99%. So alpha over 2. So we will use 2.58. So we're now ready to substitute these values in our formula. Our z alpha over 2 is 2.58 times our population standard deviation is 3,800 divided by our margin of error of 500, and then you square that one. So use your calculator, then you square. So the answer is 384.47. Okay, again, so we need to round this up to the next integer. So 385. So the general manager needs sample size of at least 385 credit card customers. And last, in measuring reaction time, a psychologist estimates that the standard deviation is 0.05. How large a sample of measurements must he take in order to be 95% confident that the error in his estimate of the mean reaction time will not exceed 0.01 seconds? So let's start first with the given. So the standard deviation is given to be 0.05. And then take note of this one. The error in his estimate of the mean reaction time will not exceed. So that is 0.01. That is our margin of error. Then we have 95%. So our z alpha over 2, 95 is 1.96. So again, we'll just plug this into our formula. So we have 1.96 times 0.05 divided by 0.01 and then square. 0.05 divided by 0.01 then square. So we have 96.04. So by the rule, we should always round this up to the next integer. So this is 97. So he must take 97 sample measurements.